by tracing using an activation record. And in case of pointers, we have seen two things a bit unusual. Aliasing, where two pointers or more than one pointer point to the same location. Changing through one will also affect the other. We also discussed a case where we have a pointer to a location and the location conceptually does not exist. Again, I'm stressing on the word concept, and also again you may observe that I distinguish between pointer and address. Address is something low level, it's just a number. A pointer is rich, it has the concept of type as well. Address has no type. When you play with a microprocessor, you play with addresses. When you program in a language like C, you play with pointers. Sometimes you take a pointer value directly, that becomes an address. I try to distinguish that clearly. Okay. The next thing we want to understand about pointers and more about memory is through these examples. What can you say about this example? And I want you to distinguish this with the one we wrote earlier. What can you say about this? Okay. So in my program, I have a variable called P on the stack. Activation record has that variable P. So we create a variable as we enter the block. So the variable P is created at line number 5. Then at this point, that's all we have. P is uninitialized. It has some junk value. Then what happens when I come into the block? What happens in line number 7? What does malloc do? It allocates memory on what's called the heap, right? A program in a state of execution is called a process. In a process, there are different areas. There is some area used by the operating system called the environmental area. That is something which you cannot directly touch. We can only access them through system calls. Come on, number. Hello? 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 Okay. So, there's some area used by the operating system called the U area. In Unix, it is very small. In case of Windows, it's half the process space itself. Okay. Then, as I said, we can modify them only through system calls like fork or exec or whatever. There is some area which is used by the program in machine language that is called the text segment. We cannot change it. There is no way we can change it. Then there is area where all global and static variables are stored. That's called the data segment. The size of which is fixed at the end of compilation, it's at the end of linking to be precise, it won't change. The remaining area in memory is available for us to play. We divide it into two parts, the stack and the heap. Stack has normally a fixed size. Heap is the remaining area. Heap is a misused word in computer science. Heap, in case of memory, is an sort of unorganized memory. Heap, in case of a data structure, is a totally different concept altogether. I do not know why both are called heap. So this, when you do a malloc, the memory is allocated on the heap. Okay. So in the stack here, we'll get a pointer to that location. Malloc is a low-level function. We have to tell it how many bytes we want. It will give me so many bytes and give a pointer to it. And that pointer will be a void pointer. It's a malleable pointer. I can convert to any type I want. I'm converting here that to int star. So through P I can access it. So if I say star of P, this P, star of P is this, in that I'm putting 10. And what happens when I come out of the block? There's no problem at all actually in this. Maybe I should do it a bit differently. Okay, I'll do a bit differently. So this P also is within the block. So when I come out of the block, what will happen? When I come to line 11, this P will die. We're out of the block, it will be removed. And how do we access this location anymore? We can't access it. So that location exists but can't be accessed. Such a location is called garbage. Okay. Make out the difference between dangling pointer and garbage. In case of dangling pointer, we have no location but access to it. In case of garbage, we have a location but no access to it. So in case of garbage, we have a location and no access. So what happens when we create garbage in a language like C? That location is gone. There's no way we can access it until the end of the program. What happens when the program terminates? What will happen to garbage? Will it remain garbage or will that be cleaned up? No resource can remain once the process terminates. So all the resources are reclaimed. Of course, in case of zombies, the child has to have something to tell the parent later. But in case of normally, all the resources are reclaimed. Memory is definitely reclaimed. So it won't remain garbage later. But during our program, we can't access it anymore. So in case of a language like C, creation of a garbage also leads to what is called the memory leak. Okay. In some languages like Java and Python, we have what are called garbage collectors. In these languages, they work differently. In case of Java, it assumes that it keeps on giving memory. When the memory falls below a threshold, a thread called garbage collector thread kicks in, and that thread has a very low priority. So what does it do? It assumes the whole of heap is garbage. Okay? It will mark everything in heap as garbage. It will go through the pointers in something called the root set, and whichever pointers point to the location in heap and there onwards are marked as useful. Again makes one more pass, whichever is not marked is collected back and made useful again. So this algorithm is called the mark and sweep algorithm, very interesting algorithm, you want to try and implement it. So Java uses something called the mark and sweep algorithm for garbage collection. Whereas in case of Python, and so also in C++ shared memory concept, we use something else called the reference count. Okay, would any of you use Unix box? Use the ln command, link command. So ln command is basically used to create one more name for a given file. But only one file, two names for it, right? When we do that, if you use the ls-l command, the second column will show you a count. A new file will have only count as one. When you ln to something else, the count goes up, right? It becomes 2 and so on. When you rm a file name, file is not removed, only the file name is removed, and the reference count is decremented. When that becomes 0, the inode, which is a file, is removed. Reference count concept is very heavily used everywhere, especially in operating systems. When you open a file, for example, you get something called the file descriptor, which is an entry in the array, and that file descriptor array is the U area. That in turn points to an entry in something called the global file, something called the global file table, that intent points to an entry in a vnode table, that intent points to the file, and file intent points to the data through pointers. Everywhere we have reference counting. So reference counting is what Python uses. Whenever I create a value in Python, it will have a count associated with it. If two different variables refer to the same value, the count would have gone up. And when you remove one of them, the count decreases. When it becomes 0, the location is removed. But unfortunately, in C, we do not have any such garbage collector. So whenever we make garbage, location is not accessible anymore. It's a memory leak, and it's for you to take care of it, right? So can you make out the difference between dangling pointers and garbage leading to memory leak? In case of dangling pointer, we have no location but access to it. In case of garbage, we have location but no access to it. Which do you think is more dangerous? Yeah? Garbage to some extent still okay, right? Let's say you have a big room like this, you can throw garbage somewhere, still you can stay in that house. Dangling pointer is dangerous because you may change something else. You may access it. Assume that you stay in a PG, right? And you get a duplicate key made to your room. You quit the PG, but you still have the key to the room. I know that you're a nice person, you won't go back to that room, but if you go back to the room, something else could happen, right? Dangling pointers are dangerous, you should be careful about it. Okay. How do you take care of that program which I have? What do you think I should have done? What did I miss out? Why did I miss out in this? Did I miss out something here? We have taken loan here. So what do you think we should do at the end of it? Run away from India? We should free, right? So free is missing here, isn't it? Once I free, there is no garbage at all. What should I say in free? If I were to use free here, what should I say? P? P followed by size of all that, right? No? Just say free. Okay, just let's think for some time. Maybe we'll also write another piece of code here. Oh, let's say I have int star p, and I'll say p equals int star malloc of size of int, and somewhere down the line I'll say p equals int star malloc of size of int times 4, or maybe I'll change the variable name to something else. Both are possible. So how would these look like? In one case, p points to an integer. What about the second case? What does q point to? When bracket is missing, I'll put it. What does q point to? It's pointing to an array of integers. Are you with me? Right? So, when I want to say free, how should I say free? Shall I say here free p? Here also say free q or something else? Please think about this. When I do a malloc, I allocate one location or allocate an array of locations. While doing free, don't you think I should also say how many locations to remove? So maybe I should also say free comma or something. How many arguments does free take? How many arguments does free take? 1 or 2? Only 1. Then what do I do in the second case? There are a row of rooms and I want to demolish all the rooms, 4 rooms. Will it demolish only first room or all the 4 rooms? How will it know? So if I look at the man pages of free, oh no, this is not the one. Okay, man -S3 free. Free takes only 1 pointer. So what do you think we should do in these 2 cases? There is no provision in free for me to say how many bytes to remove. How does it know how many bytes to remove? To do this, malloc should provide something else. Okay, this is something which I feel should be taught when somebody talks about dynamic allocation, no matter which language. Dynamic allocation is there in all languages, right? And you should talk about what happens internally. Only then people appreciate when they get mistakes. So there is something called the bookkeeping or the housekeeping, right? So this is something you should know well. So something called the bookkeeping or the housekeeping. So what malloc does is, apart from allocating memory, it will have one more location here where it will remember something like how many bytes were allocated. Maybe assuming the size of integer is 4 bytes, this is what happens. And given the value of that pointer, whatever malloc returns, internally there is a way to find how many bytes are allocated. So what I'm trying to say here is that given P, the implementation knows where this 4 is stored. Given Q, it knows where this is stored. It could be just before this location, could be a table, could be a function call, we don't know. That's an implementation issue. But there is clearly a bookkeeping. So when I call free, Q will use that value, go to the place where the bookkeeping is kept and pick up so many bytes and free it, put it back in the free list. Are you comfortable with this? This is something which you should know extremely well. So what do you think happens in that case? If I were to say instead of free Q, I say free Q plus 1. Right? You know pointer arithmetic. When you play with pointers, I can do 3 things. I can add an integer to a pointer, I get a pointer. Subtract an integer from a pointer, I get a pointer. Take difference of 2 pointers, I get an integer. It's all pointer arithmetic. It is terms of components rather than simple pointer value. So what do you think happens if I were to say free of Q plus 1? Q plus 1 is a pointer to the next location. There is no issue. Q plus 1 is well defined. It's a pointer to this. So when I say free that pointer, what will happen? From there, how many will be removed? How did you get that 16 or whatever, the 4 from Q plus 1? Given Q, I can get that bookkeeping. Is there a bookkeeping for Q plus 1? There is no bookkeeping. So what it will do? Blindly apply that formula, whatever formula is there to find the bookkeeping, go to some location, pick up some number somewhere and remove so much. Anything may happen from this point onwards. Are you comfortable? There is no bookkeeping for the value Q, for Q plus 1. There's only bookkeeping for this. And if somebody writes something like this, gone. We don't know. Right? In C and C++, so many things are not defined because the checking of this is going to be unnecessarily costly. So we don't normally do that. It's possible, actually, there are techniques called hijacking a function. We can hijack the function free and malloc, write our own function which will keep track of the pointers and so on. It was discussed in 2000 C++ journal, but normally we don't do that. In case you're interested, we can discuss offline. So please make out clearly that whenever free is called, the pointer value I use, doesn't matter what the variable name is, should be a pointer value returned by malloc. Only then we have the bookkeeping, right? Any queries so far? Okay, I'll discuss one other aspect before I change over from here. I have been saying repeatedly that when you dereference a dangling pointer, it seems to work most of the time. 99% time it works. Rarely it crashes. Sometimes you get a crash, right? 6-egg error, segment violation error. But that's not very common. Even though there is a clear error, it seems to work. So finding a dangling pointer is extremely difficult, right? Why does it happen that way? Why is that when I dereference a dangling pointer, it doesn't crash? We know it's wrong, but it doesn't crash. Okay, let me try to make an analogy. Are any of you from merchant families? Merchant families? Do you sell something? Nobody? Okay, fine. Maybe I think hesitating. I'm not going to make any jokes at you. Okay. Assume that you have a grocery shop. Okay. I'm a poor teacher, so I'll come to your grocery shop and say, I want to buy 17 grains of sugar. Assume that it is your shop, will you give me? It's on credit, I can't pay immediately, I'll pay at the end of the month. Will you give me 17 grains of sugar? And tomorrow I'll come and say, give me 22 grains of sugar. Not possible, why not? You can count and give me, no? Will you give or not? Okay, I'll be loyal, I'll pay. But I want very small quantities of something. Is it worthwhile for you to sell small amounts? Right? So what will you tell me? You'll say at least you have to buy some half a kg or 1 kg, whatever you consider as a small unit. Now what could happen when I say malloc 1 byte? Do you think system should give you 1 byte? Because there's an overhead associated with it. If it gives me 1 byte, you should remember to which process the 1 byte was given. And that will be more costlier than just giving 1 byte. So, what is the unit of memory transfer between the operating system and the process? How much does it give? I may be asking 1 byte, what do you think it will give? Can you go to a bookshop and say, I want to buy a book of 13 pages? Most probably no. They will say, maybe buy a book of 100 pages and you use the way you want. I can't give you 13 pages. Same thing happens here. When I ask memory, the OS gives me 1 page. The size of page could vary. It is a tunable parameter of the kernel. So maybe it could be 1000 bytes or 4000 bytes or whatever. That's what you get. Within that 1000 byte now you can manage. So there let's say use some 1 byte. The remaining portion is available, right? The next time I want space, I don't go to the operating system. I'll use this page itself. When I buy a book of 100 pages, I require only 13 pages. That's fine. Next I want another 20 pages. I use the same book. I don't go back to the shop for another book. Are you with me? And if I do not want those 13 pages, what do? I can't throw the whole book out, right? Similarly, when I say free a place, or when I come out from a function, that area which is popped out could be part of the page where other things are still remaining. Can you remove the whole page now? Right? There are some variables of main, variables of some function foo. We return from foo. Conceptually, the variables in foo are removed. But if the variables of main are also in the same page, can I throw the page out? No. That's the reason why differencing a dangling pointer would work, because physically it's still available. If the whole page becomes free, runtime has a choice. It can remove the page. In that case, next time you dereference, the program will crash. So see if you can make out that point clearly, that dereferencing a pointer fails when there is no physical location. Right? Logically, it's there, but physically it's not there, then it fails. Unfortunately, because the page is going to be shared, When you remove a part of it, the whole page can't be freed. Therefore, dereferencing a dynamic pointer seems to work. Are you comfortable with this? I feel these concepts should be stressed somewhere or the other. You're teaching OS, you said, maybe I think you should definitely discuss these, right? Okay. So what we do now, we'll move away from all this. Hope you're comfortable with the concept of pointers. Please read the C puzzle book and definitely read K and R. If you're not read it. Doesn't go into the brain, no problem, read again. Keep reading again and again until you get it. It's worth doing it. And there are too many books in the market today. I don't know, the book I think should be at the most 200 rupees. The C puzzle book is available on K and R, Kernighan and Ritchie. Yeah. Okay. The C puzzle book, Feuer is the author's name. I think in one of the documents I put the name. Okay. And Kernighan is a great writer. I'm a fan of his. Okay. So Kernighan has this book, the C programming language. Apart from it, he has book titled The Unix Programming Environment. Very old book that, but still a very good book to read. The programming style, software tools, defines very clearly what is a software tool, practice of programming. And for people who are starting computer science today, D is for digital. All are amazing books. And my students do lots of unusual stuff. It's very difficult to make out. So one of my students, it seems, sent mails to some people. Okay, I think I should start the other way. I have a son. So normally we go out for eating at least 4 days in a year, 3 birthdays and anniversary. At least, I said at least, not at most, not at most. 3 days, 3 birthdays and anniversary. So on my birthday, we were having dinner. I got a mail. One of your students asked me to wish you on your birthday. I'm wishing you. So see the name? Kernighan. Shock. Then I say, where is the mail come from? Princeton University. I knew he was in Princeton University. Then I found out that one of my students, Mohit Surana, now he has come back after MS and joined Google at Bangalore. It seems he sent a mail to some 4 great people in the US asking them to wish me on my birthday. And of course, only one did. So, and I sent a mail back to him saying that I just revere your books. I have all your books. The programming style, software tools, practice of programming, the C programming language, Unix programming environment, D is for digital, all books. Okay, I was digressing. Please do this, read books. The problem with, I think in your generation, you are much, much younger than me, right? Maybe when I was doing my engineering, none of you were born. We had no books in the market. We were struggling to get books. We had a course in combinatorics. There's only one book in the library in IIT Madras. It disappeared from reference section in the first week. We never saw it till the end of the semester. So we had no books to refer to, right? But you have too many books in the market today. I don't know. Less said about the quality of them. So try to get the best book to read, right? And also influence your students to read good books. And too much on the internet and many things are wrong. So avoid, unless it is clearly said it's a good thing, avoid looking at those, right? When I put my over concepts in a group in a college, one of my college students said, "Sir, I've been blogging for quite some time about all these concepts. Looks like what you're saying is totally opposite to what I have said." So that those things could happen. Okay. What do? We have 1 hour, right? Okay. We started discussing a problem. I don't think we'll be able to do much at this point in 1 hour. Okay. Another very big name in the field of optimization today is John Bentley. Okay. Any book of his is worth reading. Amazing he is. J.O.N. Bentley. You might find a couple of videos of his also on the internet, but not much videos. Okay. And most of the people we talk about, Brian Kernighan, Ritchie, have all come from AT&T Bell Labs. Lot of things I think happened in AT&T Bell Labs in the good old years. Okay, now we'll have a discussion. So you keep telling me about this. John Bentley was asked to solve a problem. There are 1 million records to be sorted. Sort 1 million records. So a friend asked him, I want to sort 1 million records. I do not have enough memory to hold them. I can't load the whole file and sort it. So what do you think we should do? Sort a huge file, that's the question. So sort a huge file which is in hard disk, and I cannot put the whole thing in memory. So what could be the possible solution? What is it? No, we can't put in memory. There's not enough memory to put it. See, B plus tree is, again, okay, that's an interesting point. How do I answer your question? If you create a B tree, it might be possible, but there are too many records there. And B tree, every insertion is logarithmic, right? Okay, I'll try to come back and answer your question. How do we sort huge files? Yeah? Divide and conquer. So what we could try to do is to break the file into parts. Okay, let's say, just for argument's sake, we'll divide it into 16 parts. Then what do we do? Okay, take one part, load into memory, sort it, write back to another file. If we do it 16 times, now we'll have 16 separately sorted files. That's not a solution, right? What do you think we should do? Okay, this is, some CEO of a company told me, assume that you are given two arrays which are sorted, and you want to combine them into another array, and that should be sorted also. What do we do? Given two sorted arrays, I want to make one more array which is sorted. What? You want to sort much? Merge, right? So how do you merge? Sorting, already it's sorted. You don't require to sort. How do you merge? How do you do? Sorting is already done. No? Merging. How do you do merging of two arrays? Merge is correct, but how do you do merging? We always sort from the beginning. You can't directly go to some other point, right? Yeah. Okay. So the way you do is compare the leftmost elements, zeroth elements, whichever is smaller, copy to the third array, and change the index, move up to the index in that particular array, and keep repeating it until one of the arrays is completely copied. Then what do we do? Nothing to compare anymore, right? So copy the remaining with no comparison at all. It seems that girl said, copy the first array as it is, and after that copy the second array and start again, right? So this is a terrible answer to give, right? Okay. In case of merging, let's think a bit. If there are m elements in the first array, n in the second array, what will be the number of comparisons? M in the first array, exact number I want now. I'm not talking about the order. If there are m elements in the first array, n in the second array, what is the number of comparisons? Huh? No, it won't be m into n, no. It doesn't depend upon that min also, because it depends on the order. There is no single answer for this. So you should be able to now tell me which is the best case, which is the worst case. It depends upon based on the worst case. They'll not be always same. If there is some way by which you can exhaust all the elements of one of the arrays, then you can just copy the other, right? Which will be the best case. That's what I think you said. Min of m comma n is the best case. That is, there are some number of elements, say m, and all the m elements are less than the elements of the other array. In that case, you do only m comparisons. So it be best case could be m or n depending upon whichever is smaller. You can hook up such a case. Rarely happens at all. What is the worst case? In the worst case, you sort of alternate while copying. Copy from the first array, then second array, first array, second array again. So what will be the worst number of comparisons? M plus? Correct. M plus n minus 1 is the right answer, right? Because at the most you can do only so many comparisons. There are n elements, you can only do n minus 1 comparisons, right? When you compare the corresponding elements, it will be m plus n minus 1. And what is the complexity of merging? What is the asymptotic complexity of merging? It is O of m plus n, and basically it's O of number of elements. It's a linear algorithm, right? Where merge sort is n log n, where merging is linear. Okay? Hope we remember the question we are trying to discuss. We have got 16 files, we said 16, could be any bigger number also. So what do you do with the 16 files? Take first two, merge them, and write out. And third and fourth, one more file. So are we saying we'll get 8 files now? We use the normal merging, we'll get 8 files. Hard disk is sufficient. No, here we only look at one element at a time. We don't load it in an array at all. Pick up the first element from one file, another file again, pick up the element and compare. We never load the file into memory. So no issue at all. So we get 16, we got 8 files. What is the next thing we should do? Again, repeat the merging. How many files do we get? 4, and then 2 and 1. So effectively we have got 15 files. As the file contents are actually repeated 4 times. Each time, if you go through the whole sequence of files, you'll get the whole content, right? So we are given a file, now we have made 4 such copies on the hard disk. And what about reading from a file? Is that a cheaper operation or a costly operation? Compared to accessing in memory, reading a file is costly, isn't it? We read the same file effectively 4 times. Each time you want to merge, again you have to go through record by record of that file or a section of the file. Is it possible? Instead of merging 2 files at a time, can you merge 16 files at a time? Can you have 16 arrays? Can you merge 16 arrays? Forget the file for time being, we'll make it easier. Can you merge 16? Okay, incidentally, what I'm discussing now is called, the article is called The Confession of the Programmer, right? So hope that makes it interesting for you. So there are 16 ordered files. How do we do? I want to merge not 2 files, 16 files together. Can I do it? I look at the first element of all the 16 arrays. Whichever is smaller, I copy to the file itself, resultant, move up to the next element in that file. Are you okay with this? Next, what do I do? Again, find the smallest out of the 16 streams. Whichever is smaller, write out and continue further. This concept is called a k-way merge. Instead of 2-way merge, I can have a k. K is 16 in my case, not 2. 16 again is a number we assumed. It could be something bigger. That's what I said. Are you okay with this? Okay, now look at the number of comparisons we do. Each time I have to do 15 comparisons. But many of the comparisons I would have done before also, right? Only one element is changing. That means I'm not even taking advantage of those earlier comparisons. If my requirement is to find a minimum each time, in a data structure where only one element changes, what is the best data structure to use? Operating system, you have number of jobs to be scheduled based on priority. You now schedule one job, a new job becomes now. Again, next time it should find which one to schedule, right? A very similar problem, like a KV merge. So what data structure should you use for supporting it? Yeah. Let's just digress a bit before we move to this. Okay, our friend is teaching OS, so definitely she has to talk about priority queue. Can we make a priority queue using an array? Whenever a job appears, I just put somewhere. Maybe I just put at the end of the array, keep putting it. Is that a good idea? In a priority queue, you do two things, NQ and DQ. So if the array is not ordered, how do you find each time which is the job to be serviced? What do you think you should do? Assuming that higher the number, higher the priority, you must find the highest value in the array. Right? What is the complexity of finding the highest in an array? What is the number of operations in the worst case? Same as the number of elements. So it will be linear. It will be linear. Right? Are you comfortable if I use the words like constant time, linear, quadratic, and so on? Right? If there is any question, please ask. So it will be linear. So find the element, then you have to shift the elements also once you remove it. If you can add at the end each time, that will be constant time. Adding at the end, you know where the end is, you can add. So if I use an array, if I implement a priority queue, removing the highest element will be linear, adding the element is constant time. Can I make the priority queue using an array in order itself, sorted maybe in the decreasing order of priority? Is that a good idea? Each time, when I remove the element, that will be from the beginning itself, but it will be still linear because I have to pack it up. I have to move the elements, right? And insertion will be linear again anyway because I have to find the location, move the elements out and make space, like insertion in the insertion sort. So both the operations would become linear. Can I instead use a list? Would that help? If I use a list, what will happen? If it is not ordered, the one with the highest priority could be anywhere, I must search. If it is ordered, then maybe it could be in the beginning. That's only constant time operation, removing the beginning of a list. But adding in an ordered list would require again to find the position before inserting. Insertion may be a constant time operation. Finding the position will become linear. So these data structures, array, ordered array, list or ordered list, are not suitable for something like priority queue, or not suitable when you have to find the maximum or the minimum repeatedly. Our friend already said the answer for it. The best data structure for this is heap. Right? So what is a heap tree? What is a heap tree? We have max heap and min heap, right? So what is a heap tree? What are the two properties a heap tree should support? Max heap, okay. And that should be recursively true for the whole tree.
Every parent should be greater than the child.
That's the first thing. The parent should have a value higher than the children. It's a binary tree. It's not a binary search tree. So the parent should have higher value compared to the children. That is called the parental control. One more requirement.
When you delete the root?
No, you can delete anywhere. It depends on the way you write the logic. So one more is structure itself, not the operation. There are two properties of a heap. Yeah? Should be complete. Every level should be full, and the last level, leftmost node should be full. Right? That's the reason how we can easily map it to an array. Right? So that's the heap tree. So in case of a heap tree, when you remove the root node, what do you think you should do? I'm assuming that all of you know heap and heapification concept. If anything, please ask. Okay, you want to try it out in the afternoon today. So when I want to remove, what do? Remove the root node, replace with the last node, and heapify the tree again, right? And that will be logarithmic operation. You just go through the heights of the tree, not every node in the tree at all, right? How do you add a node? At the end itself you add, in the last level to the rightmost or the next level beginning, and then heapify again, move backwards now, heapify towards the root. That also will be logarithmic, right? So both the operations of NQ and DQ are logarithmic. So instead of something like 15 comparisons when you have 16 values here, we require 16 log 2, which is approximately 4, right? So whenever you're required to find the minimum or the maximum repeatedly by adding and removing elements, heap is the right data structure. And heap is not used in anywhere for sorting. Would you know heap sort? Right? Heap sort is a very interesting algorithm. I love it, but we never use it. It's a beautiful algorithm. The way you can convert an array, look upon that as a heap, do operations so that the array is in order, but we don't use it. Maybe I'll come back and discuss why we don't use it with another example later. Okay. So we are discussing a problem. I don't think we'll have time to write the program today, but what I want you to think about it. So if the requirement is to do a k-way merge, use a heap and not a simple array. Are you okay with this? Okay, so what are we talking about? We are talking about external sorting, and we do internal sorting, right? How do we do internal sorting? We said we'll sort, but we didn't say which method to use for sorting. Shall we use bubble sort? No? You said no? Why? Why? N squared. And Kunu says in his book, the only interesting thing about bubble sort is the name. Nothing else. So we prefer to use algorithms with a complexity n log n. It is the best possible worst case complexity for sorting. It has been proved that there is no way we can do anything better than O of n log n for sorting. Merge sort is n log n. Heap sort is n log n. For some reason, we don't use heap sort. Merge sort requires extra space while merging, right? So we don't prefer that. We normally use quick sort. Of course, Python uses merge sort, a variation of it called tim sort. When you use quick sort, would you know who designed quick sort? Very big name from England of all places. C.R. Hoare, Anthony Hoare. He designed quick sort, and he also has a contribution in languages. The switch statement we use today came from him. In 1967 or so, he designed it. First time it was used in Pascal. Okay, so he made quick sort when he was in 20s. Now he should be 70s plus. So quick sort isn't very good theoretically. In the worst case, it is as bad as O of n log n. But over a period, when you try it out, we find that in the average case, it is n log n. It's 1.4 n log n. So quick sort is the most preferred algorithm for sorting. So if you look at the C library, it has a function called qsort, which is based on quick sort. How does quick sort work? How is it different from merge sort? Yeah, quick sort uses the concept of partitioning. Yeah, use a pivot element, bring it to the position so that all the elements to the left are less and all the elements to the right are greater. If the partitions are of equal size, it is the best case. It doesn't always happen. But even if they're a bit skewed, it doesn't really change the complexity much. That's the beauty of it, right? And there's one very interesting article, again by John Bentley. There's a book titled The Beautiful Code, which came, I think, some 10 years back. In that, there is one article of John Bentley. It is titled, The Most Beautiful Program I Never Wrote. He starts with finding the number of comparisons in quicksort, and that program undergoes number of changes, some 11 iterations. At the 11th iteration, there is no program at all, just 3 Excel columns. Through that, it shows that the number of comparisons is 1.4 times n log n. Amazing that. I think you should see the way the program changed from one step to another. I think directly get that article, the most beautiful program I never wrote. Very interesting name itself, right? Okay. So we are talking about the problem of sorting a huge file. What have we said? We'll do in 2 parts. First, divide the file into parts, bring it to memory, sort using some internal sorting technique, most probably quicksort, write them back to file, and sort using a k-way merge to merge them back. Okay? Good solution, right? That's what you would suggest to your friend if the friend were to ask you. It seems John Bentley got some doubt. He went back to his friend, asked him, what are you sorting? The biggest problem here is that we have not done any analysis of the problem at all. When I was working for a company in 98-2000 period, we were developing leasing software, hire purchase software for a particular company. We did everything. I joined the team a bit late. When we delivered it, the company said, no, we can't use it. And we missed out one thing very important for a hire purchase company, check bouncing. Check bouncing happens, and we didn't know about it because we were all computer science students, and they didn't know what they should tell us. They didn't tell us. They knew in the domain, because whenever there is a check bounce, they had to reverse the entry and also have some charge for it. That we didn't know. We didn't take care of it, right? So the most important thing in algorithms is understanding the problem domain. Analysis of the problem domain is very important. So he went back and asked, it seems, what are you sorting? And his John Bentley's friend said, I'm sorting the phone numbers of a particular area in the US. Each number is 7 digits there, just numbers. So what he was sorting were only integers and nothing really special. Right? Not sorting records or database or something. It was just the phone numbers. Maybe he wanted to know which numbers are missing or something. 2 things, he was sorting integers and all the numbers were unique. None of them would repeat. Do you think you can suggest some better way of sorting? We have said very clearly, in any comparison-based sorting, the complexity can be never better than O of n log n. If you're sorting unique integers, could there be some way to sort better? Let's say I give you some n numbers. The numbers are between, say, 1 and 100. N numbers between 1 and 100. None of them repeat. I want you to sort. How can you sort it? Can I do something like this? I'll keep here 100 buckets, number them from 1 to 100. When I get a number 5, I put something into that particular bucket, 5th bucket. When I get 2, I put something into 2nd bucket, and so on. Once that is over, I walk through from the beginning, keep picking at those numbers. Will they be in order? Yeah? Have you come across such a sorting technique? Radix sort is variation is called the bucket sort. In the radix sort or bucket sort, you may require some extra space, but you require no comparison, right? And in one walkthrough, I can complete the whole process. I don't have to come back and do it again. I don't have to have a loop in a loop, a single loop to put the elements, another loop to pick them up. That's all I require. Can you make out? This algorithm of bucket sort would make the whole thing linear rather than n log n. Linear, just walk through, O of n. Yeah, big O of n. Walk through once, put the elements. Again, walk through once more. So it will be something like O of 2, O of 2n. 2n is same as O of n. We ignore the coefficients, right? But there is still is it okay? Are you comfortable with the idea? So you don't require any comparison. So you don't have to go for some complicated sorting techniques and merging and all. But the problem still exists. I can't have all the elements in the memory. That problem is still there, right? I can't put all the numbers together. If I can put all the numbers together, I can use this bucket sort concept. Maybe actually I require much more than that because some numbers could be not there, right? It should be based upon the range and not the element themselves. Even if for 10 numbers, if I say the value could be 1 to 100, I require 100 buckets. So can there be something else? Is it possible in a single byte to store 8 numbers conceptually? In a single byte, can you store 8 numbers conceptually? Let's see if I can get the idea across. Then maybe we can try a small experiment based on it. Where is this? Okay. So, let's say we have some bytes like this. Okay. So now I got some 32 bits here. Let's assume that all the bits are 0 now. Okay. I'll number them. Maybe I can start from here. This 0, 1, 2, this is 7th bit. This is 8, 9, so on. This is the 15th bit, if you keep counting. 16 to 23 and 24 to 31. Okay. Let's say I want to put maybe 32 numbers into this. Can I do that? Let's say I have a number, what shall I take? 17. When I want to put 17 here, I'll put 1 into this, 17th bit. Let's say I get 5. So 0, 1, 2, 3, 4, 5. So I put 1 here. I want to put 20. So will that be 16, 17, 18? This is 17, no? 17 should be here. 17, 18, 19, 20, something like this. Maybe I miss one, whatever. Okay. So if the element is to be there, I put a 1. Otherwise, in the beginning, I'll make it 0. Done? If I now take all these numbers which are there, so I get 5, 17, and 20, they'll be in order. So what I'm trying to do is to do a time-space trade-off. Either the element is there or not there. For that, I'll have a position. Okay, let's look at these chairs. These 4 ladies are sitting here. Yesterday, she disappeared, so the one chair became empty. By looking at the chair, I could make out she was not there. Right? Same thing I can do here, right? The element is there, there'll be a 1 there, otherwise it's 0. But that position is fixed. Most of you are not even changing the chair. I think you should go back to the same chair, right? So by looking at the chair, I can make out whether you are there or not there. Same thing we can do here too, right? So using this idea, I'm able to store an integer in a single bit. That means I can have that 1 million records in memory itself because it's 1 million by 8. It becomes so small, right? So I can have it in memory. This is the way we can use bits better. There are, I think, certain interesting articles, I don't know where from. Maybe I can send the link to one of you later. It shows how to use the bits in a better way, right? So this is the idea. At the end, John Bender told his friend, and very interesting article to read, The Confession of the Programmer. So if somebody asks you a question to solve, don't jump into solution directly. Understand the problem. Understand what is being done. In this case, what John Bentley's friend wanted to do was to sort unique integers, nothing else. So this is the solution given. Okay. Do you think you can do this yourself? You can try it out, sort in this fashion using bits. Are you comfortable? That's a very interesting question. When I use a number to put, right, let's say for example, if I want to put this number here, some 17, I have to find, okay, in which byte it will occur. May not be byte, maybe integer in our examples. How do we get that value? This index I should get. This is an array of bytes. So if you take 17/8, size of this, I'll get this index. And if you take 17 modulo 8, you will get the position within it. That's where you should go and put it. To do that, you should know how to manipulate a bit. 3 things are required to play here. Check whether a bit is set, clear a bit, and set a bit. If you can do these 3 operations, you can do it. Right? We can do it. We can try it out, show you. It's not a problem. Any queries about this? Was this a bit boring? Was it, I don't know, or something to think about? Based on reaction, I find that you are more happy with coding than this. That's what I feel. I don't know. Am I wrong? Which did you like so far? The one year session today or this session? Or none? Okay. 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 I think we still have around 25-30 minutes. We'll look at one more example, which also brings in another interesting idea. I want to multiply 2 matrices. We'll assume square matrices. There's no problem with compatibility anyway. So let's assume that each matrix is of the order n. Each one is n cross n. What is the complexity of merging? Do we require a single loop? Require 2 loops? Require 3 loops? Require loops after loops, loop within the loop? What do we require for matrix multiplication? 2 loops are sufficient? 2 loops are sufficient? Okay. If the matrix I'm generating is C as A cross B, element in the ith row and the jth column of C, how do we get that? How do you get the element in the ith row and jth column of C? If this is A, this is B, and this is C, and I want to get some element here in the ith row and the jth column. How do I get that? Yeah? I should go through ith row of A and the jth column of B, multiply the corresponding elements and add them. So this will be sigma of ik, A of ik times B of kj, summation over k, and k varying from 0 to n minus 1. And here again, 0 less than equal to I less than n, and 0 less than equal to j less than n, right? This is the compact way of expressing the matrix multiplication. Did you study sigma notation somewhere? Sigma and pi notations? I had it in high school, I think in 10th standard. I did not understand why this sigma notation is required. I understood that during my MTech days when we were studying interpolation. There's something called the Lagrangian interpolation, in case any of you know, that can be expressed so well using pi and sigma. Without them, expressing is so difficult. This also is a pretty compact way of saying, right? Have a look at this. Do we require single loop, two loop, three loops, one within the other, one after the other? What do you think? To get one element of the matrix of C, do you require a loop or you don't require a loop? One element of matrix. To get C of 5j, what should you do? Walk through the ith row and the jth column. Walk through, that means you require a loop. To get one element of C, you require a loop. But how many elements of C do you require? Look at the first part of the notation I wrote. I require a loop to go through all the rows of C I should generate, and in each row I should all the columns. So that should clearly indicate to you that it requires a loop in a loop in a loop. Are you with me? So the normal algorithm we write is O of n cubed, right? Matrix multiplication is used very heavily, especially in linear algebra, machine learning, right? So is it possible to make it efficient? That's what people have been thinking about matrix multiplication. Can you make it efficient? Have you heard of Strayson algorithm by any chance? Strayson? You don't study? See, the usual way of writing the algorithm is O of n cubed. I can say O of n cubed is same as O of log of n to base 2, log of 8 to base 2. Can we say that? N to the power of log of 8 to base 2. In saying n cubed, I can say n to the power of log of 8 to base 2. Log of 8 to base 2 is 3. Strayson algorithm modifies it to make it log of 7 to base 2. Comes around 2.7, n to the power of 2.7, increases the number of additions, but it is very complicated for implementation. Very interesting, unusual algorithm, Strayson. It's there in any book of algorithms. Take any book worth the salt, I think you'll be able to find it. So what I will do now is this. Make an algorithm to multiply two matrices, fill some values in it. I'll assume it works. I'm not going to check for correctness. I'll try to time that program, okay? Time the program on my computer. On your computer, you may get different times. I'm only using it as a comparator. Then we'll try to modify something and see what happens. That's the idea, okay? And that should also give you an interesting idea about implementation of algorithms. Okay. I don't know whether I can complete. If I can't, I will continue it later. Yesterday we said about this, right? Why we use if and if. No, I'll make it iterative. Especially I'm looking at timing, right? So I don't want it to be recursive. What are the things we require here? to do multiplication of matrices, I can implement a matrix as a two-dimensional array, right? And so my requirement is we'll have three matrices, say A, B, C, and maybe I can start with the client also simultaneously. Okay. Even though it's not a good idea to use global variables, I'm not using dynamic allocation. On a stack, I have a problem with size, so I'm creating it outside itself. Okay. Because otherwise, I won't be able to have such a big size. So I'll have three matrices. One more thing you would observe that every time I make a variable, it's a separate statement itself. It's never combined together. It's a bad idea to combine together, especially if your pointers, it may give a wrong idea, right? Let's say, for example, if I were to say int star p comma q, what does it mean? What type are p and q? P is a pointer, q? Is q a pointer or integer? Here q is an integer. To avoid such problems, declare one variable at a time. So what are the things I should do here? Okay. So what I want to do is, I want to initialize the matrix. Okay. And I want to initialize the matrix B. And then I initialize the matrix C. In the beginning, I'll put zeros here. Maybe I'll call it read. Then I multiply matrices A comma B, A, B, get the result in C, and the order is this. Okay. My requirement is to just find the time of it. I'll also introduce the code for it. This is what I want to do. And that implies that in my header file, I must have support for. Please do not worry about the signature. I'll come back and talk about that later. So if done correctly, this should compile. Two required or three required? I think I'll make my life a bit easier. Okay. So let's go through the implementation quickly. And to populate the matrix, I'll do something like this. I'll call the random function. and take modulo with respect to 1000, some value which is filled up randomly. Okay. And the last routine I should write is this matrix multiplication. So I'll have a loop in I. A loop in J and a loop in K. And within the loop in K, I will have the summation. And then link the them together. So there's no output there. It took some time to come out because we are multiplying huge matrices, 1000 by 1000. So it may be doing something like 10 to the power of 6 operations at least. No, 10 to the power of 9 operations. 1000 times 1000 times 1000, right? 10 power 9. So the basic idea is to show the timing so that I can compare with another one, right? So to do the timing, I won't remember, so I had something picked up here. Okay. So if I want to do some typing, I require some of these. I will do one thing. I'll copy this portion. Okay, one of them I can use. I'll use this. And so I will add the code at the right place. Okay. So in the client code, I will use the time.h that's required for timing. I will have a function which will find the time for me based upon these. These variables, I will put them within the main here. Okay. Then to start timing, I will use this. So I'm only timing the multiplication, so I'll use it here. So it starts holding the starting time. When the operation is complete, I will use another variable and to hold the time. And to display how much time was spent, I will use this function call. Okay. And then I also require this function. That function can be here. Okay. So I change the client code to measure how much time the program will take. Okay. Yeah. So it may take a few milliseconds, I don't know, maybe some few seconds. Okay. And it can vary a bit, so maybe we'll run this a few times so we get a feel of how much it may take. So it's taking some 9 point some seconds. It's a simple, straightforward implementation of matrix multiplication. Oh, it took 12. So around that order, right? So that I think should be a good idea. Okay. So maybe we can leave off the outliers and pick up the one in the middle. So I want you to observe the algorithm for multiplication. Okay. Think logically. If I interchange the order of looping, will that affect the correctness of the algorithm? Instead of ijk, I make it jki or something else. Would that change the algorithm? Okay. If you observe, it doesn't really matter. Anyway, this operation is being done, so it's building up the result here. Whether we do it together or in parts, it doesn't make a difference. Would it matter if I change the order of indices? Same algorithm, no change. Can I change the order of indices? Would that matter? Would that have any effect on the timing? Shall we try? Okay. So what I will do now is to remove this piece of code. This is the way to remove a piece of code, not by commenting. Use the preprocessor. Okay. So what I will do is this. I will put J here. Okay. And I'll put K here, doesn't matter. Are you with me? The only change I made is interchange the jth loop on the kth loop. I changed the implementation. The client hasn't changed. And now let's run and see. What do you expect now? Will I get some 9 seconds only, or will that be different? Do you teach linear algebra? Is that part of your computer science courses, or is it department of math which will do it separately? Math will do it, and they don't like computer science. And the computer science teachers won't like math, right? There should be some synergy, right? They should work together. If somebody teaching linear algebra should also digress to talk about computers and talk about this. What is happening in this? I didn't do any change, just change the loops. How come it changed? Some magic. Maybe a good thing to think about over lunch, right? Okay. So we'll break now for lunch. Time, right? How much time do you have? 5 minutes, okay. So 5 minutes is fine. You may require to think about this. So we'll come back and we'll then answer it. And look also about something about bits I've mentioned. And then we'll have a lab session. So how is it today? Huh? Oh yes, you should require this. Right? Yeah. Was it lighter today? Lighter today? Or was it heavier than the first day? Okay, okay then. We'll meet at 1 o'clock.